Today I'll be talking about the thermodynamic process. The first one is the adiabatic process, in which there's a zero heat exchange, and by the first law of thermodynamics, we're just left with a change in internal energy minus the work. And in certain ways where this can happen is where you have a system with an insulator, where there's not enough time for heat to exchange, and there's an adiabatic process that expands that causes positive work on the surroundings with a change in negative internal energy, or a compressive adiabatic process with a negative work and positive change in internal energy. In the next thermodynamic process, we have the isochoric process, in which there is zero work done on the surrounding or on the system. With this, we are just left with change in internal energy equals the heat exchange. In this process, we have a constant volume. An example of this is where you have a sealed inelastic container in which heat is provided to the system, which results in a rise in temperature. And so you have a rise of heat, which is a rise of internal energy. The next thermodynamic process is the isobaric process. The only difference between this one and the other ones is that this one is at constant pressure. When you have constant pressure, all your quantities cannot equal zero. That's including internal energy, work, and heat. An example of this process is if you have a movable piston in which no matter how much the piston moves, it's still at atmospheric pressure. You have some sort of gas in this piston in which when heat is added, the piston will move, leaving it at constant pressure. And this equation can be left with work equals pressure times change in volume. In our last process, we have the isothermal process, in which it is at a constant temperature in which none of the quantities equal to zero, but there is a special case with an ideal gas, in which we use the ideal gas law, PV equals nRT, in which work can equal nRT natural log of second volume over this first volume, in which T's constant change in internal energy is also constant. An example is a phase change of ice, which does not change temperature until it fully melts and just stays at zero.